So now we are having the 7th question. It's actually a very easy question. We have to prove the first matrix to be a symmetric one and the second one to be a skew symmetric one. So for this question, what we have to do means, first A matrix is given, right? We have to prove its symmetry. So for that we have to find the transpose of the matrix A dash, right? Now take the first row and make it into the first column. 1 minus 1 5. Now the second row becomes the second column. Minus 1 2 1, and third row becomes the third column. 5 1 3. Now compare this with the A matrix. If you compare, A dash will be equal to A, right? Each and every element, it is same, right? They are equal. So that's why, as both the transpose and the real matrix are equal, the given matrix is symmetrical, right? It's a symmetric matrix. Now for the second part of the same question, we have to prove that this matrix, if it is skew symmetric or not, right? So for that, let's take the transpose again. So first row becomes the first column, right? Second row becomes the second column, and third one becomes the third. 1 minus 1 0. So now you check, right? A dash and A, you compare. 0 0 minus 1 1 1 minus 1 minus 1 1 0 1 0 1 minus 1 1 minus 1 minus 1 1 and 0 0. So if you compare, instead of 1 we are having minus 1 here, and instead of 1 we are having minus 1 here, right? So both are having just the opposite signs, right? So A is equal to negative A dash, right? Just it's equal to A dash, but just the symbol is opposite, right? The symbol, so it's a negative symbol, so it is skew symmetric matrix. So thus we have proved this is a skew symmetric matrix, right? So in the 8th question, A matrix is given. Just we have to prove that A plus A dash is symmetric and A minus A dash is skew symmetric. So let's first do A plus A dash, right? So for that, first you have to find out A dash, right? A dash is a transpose. So first row becomes the first column, 1 5. Second row becomes the second column, 6 7, right? Now we have to do A plus A dash, right? Now for this one, you can do A is 1 5 6 7 and A dash is 1 6 5 7. Just we have to add both these matrices together. 1 plus 1 would be 2, 5 plus 6 would be 11, and 6 plus 5 would also be 11, and finally 7 plus 7 would be 14. Now what we have to do means, this is our A plus A dash matrix, right? Now let's do A plus A dash whole transpose, right? So the first row becomes the first column, and second one becomes the second column, right? So if you compare the real matrix and the transpose matrix, right, both have the same elements in the same places. So when both are equal, right, the transpose and the real matrix are equal, this means that it is symmetric. So A plus A dash is symmetric, right? Now let's do A minus A dash, right? We already found out what is the A dash, right? Same thing we have to use now also. So A is 1 5 6 7 and A dash is 1 6 5 7. Now just do the subtraction. 1 minus 1 would be 0, 5 minus 6 would be minus 1, 6 minus 5 would be plus 1, and 7 minus 7 would be 0. So let's take A minus A dash whole dash, right? The transpose of the matrix. Now take the transpose of this, right? 0 minus 1 and 1 0. Now compare these two matrices together, A minus A dash and A minus A dash whole dash, right? So if you check, instead of 1 we are having minus 1, instead of minus 1 we are having 1. right? So the symbols are reversed, right? So this is like equal to a minus a dash is actually equal to negative of a minus a dash whole dash, right? So this means that a minus a dash is a skew symmetric matrix.